This video goes through the review sheet for Test 1 in Calculus AB. I'm probably going to split this up into two videos, so I'll have questions 1 through 10 in the first part and 11 through 20 in the second part. So let's get started. This is question 1. It asks you to find the limit as x approaches 3 from the right side. So we're coming at 3 from this side, and as we follow the graph here, we see that it goes up to positive infinity. So that's our answer. Remember, it's completely fine for a one-sided limit to have an answer of positive or negative infinity. Now on this one, number 2, it says find the limit as x approaches negative 1. It does not specify a side. That means it's a regular, or you can call it a two-sided limit. So we have to take both into consideration. Well, as I come from this way, it's heading up to infinity, and as I come from this way, it's heading up to infinity. But I'm not allowed to have infinity as my answer for a regular limit. That's one of the reasons regular limits don't exist if it heads toward infinity. So I have to answer does not exist. Again, the difference between number 1 and number 2 is that number 1 is a one-sided limit, and for those you are allowed to answer infinity. Number 2 is a regular limit, and you are not. So here we have a one-sided limit, x approaches 4 from the left. I would just recommend you do this in the calculator. I'm going to make this a little bigger just in case you can't see. There we go. So we will plug this in. Make sure you put the numerator in parentheses and the denominator. And we want to approach 4 from the left, so we need to think of what numbers would be just to the left of 4. That would be 3.9, 3.99, 3.999, and so on. Hopefully you can see that this is just continuing to get bigger and bigger in a negative way. So it's getting bigger and bigger negative numbers. So if we're getting bigger and bigger negative numbers, that means we are heading toward negative infinity. And that is our answer for number 3. Again, it's a one-sided limit, so that type of answer is allowed, negative infinity. Okay, number 4. It says find the limit as x approaches 2 of 3x squared plus 7. Well, it's a regular limit, so the first thing you should always try is just direct substitution. Just plug it in. 3 times 2 squared plus 7. So 3 times 4 plus 7, 12 plus 7 equals 19. So when it's a regular limit, the first thing you should always try is just direct substitution. Number 5. Find the limit as x approaches 3. Okay, so let's try plugging it in first. I'm going to go ahead and factor because I suspect we may have to anyway, and this will make it easier for me to plug in that 3. Let's see. Okay, that factors, and now it's actually pretty easy to see. If I try to plug 3 in, I get 0 in the denominator, so that's a problem. So I can't just use direct substitution. But since it is something that's factorable, that tells me I can use dividing out, which is what I've done here. By factoring it and then dividing out the common pieces or canceling them out, now I am able to plug in the 3. So if I plug 3 in the top, I get 3 plus 3 is 6. Plug 3 in the bottom, I get 3 minus 1 is 2. So my limit would be 3. Okay, this one. It's a regular limit, so your first try should be to plug 0 in, but hopefully you see that causes a problem because we get 0 in the denominator. And this one has radicals, so hopefully you know right away that means we need to use rationalizing. But that means we need to multiply by the conjugate. So we just change this sign right here. Never change the sign inside the radical. We just change the sign in between them, and then we're going to FOIL the top. Square root of x plus 7 times square root of x plus 7 is x plus 7. And then if you notice, the middle terms cancel. Positive square root of 7 times that, negative square root of 7 times that, those are just going to cancel each other out. So then the last terms, negative square root of 7 times square root of 7 is negative 7. And on the bottom, I'm not going to bother distributing. I'm just going to write it just as it is. So on top, 7 minus 7 cancels, leaving just x on top. Then the x's cancel, giving you just 1 over the square root of x plus 7 plus the square root of 7. Now we can finally plug in that 0. Back here originally, that's what we're trying to do, is plug in 0. If we do so, we get 1 over the square root of 7 plus the square root of 7, which is equivalent to 1 over 2 square root of 7, or if you rationalize the denominator, you should get square root of 7 over 14. I would accept either one of those answers as fine. Okay, number 7. Again, it's a regular limit, so I would just try direct substitution, but that won't work because it gives me a 0 in the denominator. Now this one is fractions inside of fractions, so you should know anytime you see that it needs to be the common denominator method. So I multiply this side, top and bottom, by x plus 6, this side, top and bottom, by 6. So that gives me x plus 6 over 6 times x plus 6 minus 6 over 6 times x plus 6, all divided by x. Now that they have the same denominators, I can combine them. X plus 6 minus 6 just gives me x. And what I really have here is a fraction over a fraction. If I just put that x on the bottom over 1, then I have a fraction over a fraction, and I know to divide fractions I have to multiply by the reciprocal. So then x's cancel out. I get 1 over 6 times x plus 6, and I can plug in 0 now and get 1 over 6 times 6, which is 1 over 36. Number 8, this is using the properties of limits. So they're giving you the fact that the limit for g is 4 and the limit for h is negative 3. Notice for both of those that says x approaches 1. Now, it says what is the limit as x approaches 1 for g of x plus h of x over 3 times h of x. In other words, if we took the two functions we have right now, g and h, and rewrote a new function by adding the two together and dividing by 3 times h, what would the new limit be? Remember, this is just a matter of substituting. So I know the limit for g is 4, the limit for h is negative 3, and so I plug it in for both of them. So I get 4 minus 3 on top, and then 3 times negative 3 on the bottom. So that's 1 over negative 9, so we get negative 1/9. Okay, this again, it's a regular limit. You should always try direct substitution, but lo and behold, you get a 0 in the denominator. But this one isn't factorable, at least not in the normal sense of the word. It's also doesn't have any square roots, so we couldn't rationalize, and it's not a fraction inside of a fraction. But if you rewrite this as sine of x over x times sine of x over 1, because that's the same thing, sine times sine is sine squared, then hopefully you recognize this piece right here, because that's one you're supposed to have memorized. The fact that the limit as x approaches 0 of sine of x over x equals 1. And then this one over here you can use direct substitution. If you plug 0 in for x, sine of 0 is 0, so you just get 1 times 0 for a limit of 0. Okay, this is the last question I'll do for this video. We'll put the other 10 in the next video just to split it up. This again is one where you should have it memorized. So if you notice, you just pull the 3/4 out front and you get 1 minus cosine x over x. This piece is something you should have memorized, that the limit of it as x approaches 0 is 0. So you get 3/4 times 0, which is 0. As I said, if you want the answers for 11 through 20, please see part 2 video.